So now we talk about question 11. Question 11. Question 11. So this question 11, year 2022, paper 1. Okay, I think you can use that uh, the material from the A levels 10-year series. A gas company has a plans to install a pipeline from a gas field to a storage facilities, and one part of the route for the pipeline has to pass under a river. This part of pipeline is a straight line between 2 points P and Q. So straight away you know P and Q. The points are defined relative to the origin 0003D, yeah? And at the gas field, X, Y, Z axes are in the direction east, north, and vertical outwards. Okay. North, east, and vertical outwards. So this is the XYZ direction. North is what? North probably is Z direction. Y direction. This is X direction. Probably this is Z direction. So then it says that P has a coordinate of 1136, 92 P, and D1 Q had a coordinate of 200, 20, and minus 15. Okay, so these are the coordinates. The length of the pipeline PQ is 939. Given the level of P is below that of Q, find the values of P. So now we have given that they say that QP is lower than Q. If you draw in 3D, P is lower than Q, and this distance is 939. So ask us to find the values of P. So we will look at what is meant by lower. Lower means that it is a vertically outwards for Z direction. The Z value is lower. That means that P have to be less than minus 15. It's lower, right? So then we this is the condition that we set. So we know the distance formula. X1 minus x2 square plus y1 minus y2 square plus z1 minus z2 square. So this is a distance formula. Then we just sub it in. 393 equals to square equals to z1 is what? 1136 minus 200 square plus 92 minus 20 square plus p minus or plus 15 square. So ultimately what we get? So ultimately we'll get this equation: p square plus 30p minus 216 equals 0. So we'll get this thing. So we factorize this. Okay, so this 261 is 36 over 6. Okay, because you know that this is 6 to the power of 3. So this is 36. So is this minus, right? So it's minus, is plus 36, and then p minus 6 equals 0. Okay, so we know that p have to be less than minus 15, which means that p is to be minus 60, 36. Okay, so because these have to be less than 36, 15. So this is the answer. P is minus 36. So we get the 3 marks done. So then we look at question B. A thin layer of rock lies between the ground, and this layer is modified as a plant. The 3 points in the plant are, right, these are enough questions. A rock is lying below the ground. Okay, below ground means that it probably, the Z coordinate is minus. Okay, and it's below the ground, and this point on the plan is, okay, 400, 60, 600, and 200, 20, 500, 200, and minus 70, and this is 600, minus 340, and minus 50. Find the Cartesian equations of the plan. So there are many methods we can do that. So we let A, B, C are the point. I rather you use the vertical form to represent that, because it's easier and it's easier to spot mistake if you really have problem. So the vectors of A-level syllabus are not so difficult, only plan and line. So we know that this is plan and line. So which mean, okay, this is, when we look at these 3 point form a triangle, and this triangle form a plan. So this triangle form a plan, which means that the dot product, the cross products of these vectors, let's ABC, AC cross AB cross AC will have to be equals to a normal, because we cross the thing, we get a normal, right? A normal n times the OA or OC, whatever you call it, dot OA or OC. So this these will be the normal product. When a normal product dot directional products, OA, a normal dot the directional products, what will give you is a cosine theta with the magnitude. So this cosine theta with the magnitude, it is actually the same directions of this. This is the unit vectors. So we need to find AB and AC. So ultimately what you get from AC is that AB is that 50 minus 2, 8, 1. So how do you do that? Use the OB minus OA. So you just need to, from the back minus the front. OC minus OA will give you 10, 20 minus 90 minus 3. So you can either use calculators or you can do the dot products for these. The dot product actually, you need to do the, we call it the determinant, but at the moment I think you can use the calculators to do that. So ultimately you will get 14,512. So 14,512, you know that this is the normal to the plan vector. One of the normal to a plan vector is 512. We choose 512, okay, because it's easier to manipulate. You don't choose those with decimal numbers. So a vectors which is r dot n will be equals to a point dot n. A point, the unit vectors dot n will give you a vectors in the plan dot this thing. So which means that this is a perpendicular vectors, and you have a A here, and with any plan R here, okay. This vector dot these vectors, okay, because when they dot, okay, they'll give you the same magnitude. So this is the beauty of a plan. This is the definition of a plan. Okay. So then our cells is equal to 512 equals to OA. You can use the OA. OA is the vectors that we have found. 400, 60, 600 minus 20, 512. So you just need to dot it. Dot it is just multiply and cross it. Dot will give you a scalar product, which is 502560. So then you have these already, we know R vector is xyz. So we need to dot it, become 5x plus 1y plus 2z equals to 2560. So easy peasy. And this is 4 marks. 4 marks. Correct. The other questions, the questions number C, find the coordinates of point where the pipeline meets the route. So which means that the pipeline is that we have equations of the line, and we have the plane equation. So we need to find the intersections of these equations. Correct. So just now we have already found that the p value, it is minus 36. Minus 36. So then we further find that PQ vectors, it is OQ minus OP. So OQ minus OP, which will give you minus 936 minus 72 minus plus 221. So this is the line vectors, the direction vectors. So the line equation will be equals to a point OP plus mu or lambda, anything, times the directional vectors. Correct? We should give you something like that. Use mu, we use mu. Where mu can be any numbers, any real number. At the moment is real number. So this is the equation that we have. However, the line, just now we have found that the plane equations is this. So what we need to do is that we need to solve these simultaneous equations. Okay, we need to solve these simultaneous equations. Okay. So we can see that 5 times x, we just substitute the x here. X here, for these unit vectors, x here is equals to 200 plus 936 times mu. Y is 20 minus the 22 mu, and z is minus 15 plus 21 mu. So you need to just type it in. See, you have a linear equation with one variables only. Which is equals to 2560. So ultimately you get your mu, which is equals to minus 1/3. So now you sub it in again for this xyz. So it's 200 minus 361 minus 1/3. You get a very big parenthesis, and ultimately you get 512 42 minus 22. So these are the things that you will get, okay, for question C. Then the fourth question is asked that is 2 marks. Find the angle that the pipeline between the point P and Q marked with the horizontal. So the pipeline between P and Q, point P and Q marked with the horizontal. So we know that PQ is this line. Just now we find it marked with the horizontal. Let's say this is a horizontal line. That means that what is the angle of this line? So how do we get to do these questions? Any ideas? You can use the what type of formula is it? We know that this is a vectors. We have found these vectors PQ. Okay, PQ, we found these PQ vectors. And if, let's say if this is a horizontal line, Z is here. So horizontal line Z, the vertical line of Z with the horizontal plane is equals to 0, 0, 1. Correct? 0, 0, your unit vectors. So if PQ dot the normal vectors of Z, if it give you look at the fundamentals formula that we had. If I dot two products at here, so you look at the vectors formulas. If I dot with this vector, what do I get? I will get the OP PQ times the magnitude of PQ times the magnitude of the unit vectors. So that PQ just now we know we found it already. You can just write it down. Now we need to find that is a Z here. So it is actually equals to 936 minus 27 minus 21, and you dot it, and equals to psi theta. Unit vectors, you have a magnitude of 1 PQ. So psi theta ultimately will be equals to 2193y, and then your theta is actually equal to 1.3 theta, the degree, so to 1 decimal point. Okay, so I think that's about all. You need to revise that when we do about dot products. When we cosine theta, then we dot the cosine theta product and the sine theta product. What is the difference does it make? So then you look at the textbook, and then it will explain to you further. Okay, thank you.